Hey guys, no Fanfic Friday today, and that is because I'm still working on this really cool project that I want to get done, because I want to make Fanfic Friday a lot cooler. So instead, I took a short break from editing the really cool thing that I really want to tell you guys about, but you guys will just have to wait. So, I got bored though while I was editing, because video editing is a pain in the butt. And I decided, while I was looking for some clips, I saw this one clip where Ladybug was hovering using her yo-yo. And I wanted to find out how much force does that exert whenever she's hovering like that. And she wasn't exactly hovering, she was still moving downwards. So, I'd say she was like about 0.75% of hover, I guess, is, I don't know, I just threw in some random numbers for that, and I was like, you know what, I'm gonna do the math. So I did. And the first things I needed was, I needed Ladybug's height and weight. I needed Ladybug's height to find her weight, because, you know, we're never actually told any of this, because it's impolite to ask a lady's weight, you know? So first things first, Ladybug's height is 1.66 meters. That's found through, you know, data analyzation and junk like that from the show itself, because, yeah. So then, plugging that in, for a girl about her age, and that height, that makes her weight about 58 kilograms. Now that we have that, we can find out what type of lift is needed to slow her down to a point about 0.75% of a hover. And what we do there is, it's simple. We plug in her weight, the acceleration by gravity, and then we just times it by 0.75. So that's going to be 58 times 9.8 meters per second, and then times 0.75, which gives us 426.3 newtons. So, now we need to figure out how much lift that, now what we need to do is use the lift equation to figure out the velocity that her yo-yo was going. Because we're trying to figure out how much force is being exerted. So we need velocity. And the velocity here can be found pretty easily by just plugging in a couple of things to the lift equation. Now, lift is equal to the coefficient for lift times the air density times velocity squared divided by 2 times the area. Now, I'm just going to go ahead and tell you, I figured all this junk out. 426.3 is the lift that we're trying to go for. Now, that equals 0.3 is about the coefficient for a yo-yo of that size. I don't ask how I got those numbers, because I had to do a lot of stinging looking up junk. Next up, air density. Luckily, Paris is very, very close to sea level. So we get 1.225 for air density, because that's just air density at sea level, and we can assume that it doesn't change too much. Next up, since we're looking for velocity, so we skip that. So then we go to area. And area there, I found out after a little bit of digging that the radius of that circle is about half a meter. So, you know, the circle that her yo-yo makes is about a meter exactly, which means the area is about 0.79 meters squared. So we plug all of that in, and what we end up getting is the numbers 2936.7. 2936.7 velocity squared. That is the velocity squared. We'll keep it squared for now, because of the fact that we don't need it unsquared for the next equation to find out the force. So, since it's traveling in a circle, we use the centripetal force equation, which is force equals mass times velocity squared over r, which is radius. Now, we already know, now, the mass is never told to us for the yo-yo, so I had to guess. And I guessed it was probably about a half a kilogram, which is about 1.1 pounds to you Americans out there. And then, of course, you know, velocity squared is 2,936.7. Divide that by another 0.5, because that's the radius of the circle that she was making. And, well, you can cancel out the 0.5s, and you end up getting 2936.7, aka, you know, the velocity squared, is the force, the centripetal force, actually, exerted. Now, let's go ahead and just, since that's a really random number, let's just round up to 3,000, because it's very close to 3,000. Now, what can you do with 3,000 pounds of, 3,000 newtons of force? Well, for one, you can actually crush a skull with that. It takes 2,200 newtons of force in order to break someone's skull. She's exerting almost 800 newtons more than that, though, meaning she can easily crush someone's skull with her yo-yo, and that is a little bit terrifying. There's actually a lot of things that you can break on a human body. I honestly almost feel bad for the bad guys, like if they weren't healed, because, oh goodness, there'd be a lot more broken bones. But, yeah, this is me procrastinating on a project. I should probably get back to that now, though. Thanks for watching, and trust me, I will have a video out as soon as possible. Probably Fanfic Friday, possibly a comic dub, and who knows, maybe a little bit of John Cena. Thank you all for watching, and have a wonderful day.